Hello, in this lesson we are going to continue to talk about rational numbers, and we're going to throw in some stuff to do with operations, which basically means just operations with fractions for the most part, but we're also going to combine in powers. So hopefully you're feeling comfortable with powers because we covered that before, and it's it's something that's going to, it's just another operation that we're going to work with, right? Powers. Working with fractions is something we're going to work with. You want to be comfortable with each one of these things because what happens in math is we put things together and then that adds different levels of complexity. So if you're not feeling comfortable with the rational numbers yet, you might want to go back and review that part of the course. Same with powers, because we're going to keep coming back to them. So it's not like it's going to be a one and done or even a two or three and done. Going to keep coming back to them. So really make sure that you get each part before you go on to the next, okay? But assuming that you are comfortable with them, let's dive in. Few tips for working with rational numbers. When you're adding and subtracting, simplify any double signs, then rewrite all negative fractions with the negative signs in the numerator. So when we look at one like this, this first example here, negative 2/5 plus 1 over negative 4 minus 1 over negative 1 over minus 1 over negative 2. There's a lot of sign simplification we can do. If we see two signs in front of a fraction anywhere, like this plus sign and this minus sign, or like this minus sign and this minus sign, we want to simplify that. So I would rewrite this as negative 2 over 5. That part doesn't change. But that plus and that minus, we've learned before, one of each simplifies to a minus. I just put that in between the fractions. We have to have something in between our fractions. I know that we said, oh, well, okay, always put our numbers up top. But that doesn't apply in a situation like this, because it wouldn't make sense to have it like this. It doesn't really read like an expression, does it? We need to have the negative sign in between the two fractions in this case. In the first one, it makes sense to put the negative sign up top because there's nothing, we're not subtracting or, or adding it to anything. But we definitely, sorry for the jumping around there, but we definitely want to have something between our fractions. Think of that minus sign as if it's on the numerator, even though I've put it in between them. As far as the green one goes, we've got two negatives, and therefore that becomes a positive. Again, I'm going to put that between the two fractions, though. And then I could carry on from there. I could get a common denominator. I could add or subtract the numerators as necessary. But we'll do that in another example. Don't forget about order of operations. Look at all the things that's going on in this one. So bedmass, brackets, then exponents, then division and multiplication. Those are equal, whichever comes first. Then addition and subtraction, whichever comes first. So a question like this shouldn't throw you off. In fact, you shouldn't even have to think about it, so to speak. Obviously, you need to engage your brain. But there shouldn't be any pondering or soul searching. It should be, if you understand order of operations, the first step should be immediately obvious to you. You see what the first step is? Change that 3 to a negative 4, 3 minus 4 to a negative 1. Sorry. And there's a few other things that we could do. But again, this isn't really an example so much as well, it's an example, but not one to work through. And remember, as I've said before, it's easier to work with improper fractions. I say always change a mixed number to an improper fraction when you're working with it. If you want to change it back when you're done, go ahead, but don't work with it as a mixed number. So here's a few examples of different things that you might come across. Here's a word problem to start with. The formula to convert temperatures between degrees Fahrenheit and degrees Celsius is C equals 5/9 times the Fahrenheit temperature minus 32 in brackets. Use the formula to convert 8.5 degrees Fahrenheit to Celsius. All right, so that means we're going to do a little substitution. We're going to put negative 8.5 in for F. So I'm just going to take a step to write it in there. Negative 8.5 minus 32. And that's all I did in that step, was do that replacement. Now I need to get order of operations in there, but I also need to deal with decimals and negative signs and fractions. So let's see what we can do. I'll start with the brackets like I always should. And I'm subtracting. I got two negative numbers. So remember, one technique we could do for that is just add them together in this case and then take the sign. So I could do 32 plus 8.5 and I get 40.5. And then just put that minus sign out front. Now, if I want to take 5/9 of that, and of course I could type this in my calculator, but that's not what this is about. This is about understanding how to do stuff like this without necessarily making it a calculator question. I could change 40.5 to a fraction. An easy way to do that is just look at my last place, my last decimal place. We've talked about this before. If my last place is a 10th place, as this 5 is, then I can move the decimal place over 1 and put it over 10. So that's what I'll do. So instead of doing 40.5, I'll write it as 405 over 10. And I'll put the minus sign out front. So now we're multiplying, but we got some big numbers. And I can definitely do a little reducing anyway. I know that 5 goes into itself once and into 10 twice. 405, let's see. Can I divide 9 into 405? 9 goes into 360. I think 9 goes into 405. It's going to go into itself one time, of course. And 9 is going to go into 405 45 times. I'm pretty sure it's 45 times, but I do think that I will go for a calculator for this one. 405 divided by 9, 45. You can see it on the right-hand side. So look at that, 45 times. Good show. All right, multiplying. 1 times negative 45 gives negative 45. 1 times 2 on the denominator gives me 2. So negative 45 over 2, that's not really a useful way for expressing a temperature, is it? So in this case, it would make sense to, for sure, to make it back into a mixed fraction. 2 goes into 45, 22 times with 1 left over, so 22 and a half. Put the negative sign in front of the whole thing, and that's going to be degrees Celsius. So I did use my calculator just to confirm that 405 divided by 9 was 45, but otherwise we were able to do most of it without a calculator, and that's a really good goal for this course, to try to avoid calculators as much as possible. Next example, we've got a couple fractions. We're subtracting one from the other. We need a common denominator. For adding and subtracting, we do need a common denominator. Only for adding and subtracting, though, right? 4 goes into 8, so we can use 8 as our common denominator. If I multiply the top and bottom by 2, giving me 6 over 8, I've got a common denominator. Now, when I'm subtracting, as with adding, I only do the numerator. So I'm going to leave the 8 on the bottom, and I'm going to deal with the top. So think of the signs. Remember, whether I write the sign up in the top or if it's between them, think of the sign as always being on the top. So think of it like negative 7 minus 6. Since they're both the same sign, I can add them together. I get 13. And I can just take the negative sign and put that on top. And I'm going to leave that as an improper fraction. I have no reason in this case to switch it to a mixed fraction. In part B, it's multiplying. We absolutely do not need a common denominator. In fact, I would strongly urge against getting a common denominator. I would rewrite it with the negative sign on top, though, just to keep things consistent. I'd look for anything I can reduce, but I don't see anything. And then if I do top times top, negative times negative is positive. 8 times 2 is 16. Bottom times bottom, 9 times 5 is, pardon me, 45. And since I've already checked to see if there's anything I can reduce, and there wasn't, I know that's my answer. Here we've got mixed numbers. I would 100% change this to improper fractions. 8 times 3 is 24, plus 2 is 26. Over 3, put the minus sign up top. Plus, 4 times 6 is 24, plus 1 is 25, over 6 on the bottom. Put the minus sign on top. Combine these two signs. This plus and the minus is going to combine to give a minus overall. Okay? So I'm going to have a minus overall. I want to get a common denominator. Since 3 goes into 6, I can use 6. I just have to multiply my top and bottom of my first fraction by 2. 2 times 26 is 52. And so it would be negative 52 minus 25 over 6. Again, I would keep my denominator the same. So it's going to be 6 on the bottom, and it would be negative 52 minus 25. And again, since they're both the same sign, we can just add them together. 52 plus 25 is 77, and put the minus sign out front. Again, I don't see any reason why I would need to switch it back to a mixed fraction. It started as a mixed fraction, so if you really wanted to, I know that 6 goes into 77 12 times, with 5 left over, and the minus sign would go in the very front. Last one. Once again, I need a mixed fraction. Sorry, I keep saying mixed. I mean to say improper fraction. 5/6 is already good to go. But I would change 1 1/4 to 5/4 with the minus sign on top. I would flip the second fraction, leaving the minus sign on top so it becomes negative 4/5. I would reduce 5 and 5 cancel out, so to speak. In other words, they both become 1. And so 1 times negative 4, actually, okay, I could reduce. As I started writing it, I realized I could reduce farther. So let's pretend I didn't notice it until I was totally done. So 1 times negative 4 is negative 4 over 6. That can reduce. I can divide the top and bottom by 2, giving me negative 2 over 3. Or I could have reduced farther up, right? I could have divided the top and bottom by 2 in that other step where I reduced the 5s. Either way, I do have to reduce at some point, and so it's important to make sure I do that. Calculate, round to the nearest hundredth. All right, now we've got some decimals involved. I would say that if a question gives you decimals, it's okay to use decimals. I don't want to combine decimals and fractions. Like in this first part A, I've got this negative 3.5, whereas everything else is decimals. I would say I'd probably, in this case, change the 3.5 to a decimal. I might as well take care of that sign at the same time, right? Those two negatives become a plus. And so I would change that to plus 3.5 minus 0.62 times 4.5. That could be done on my calculator all at one time. One drawback to using a calculator in the same iPad as I'm recording this video is I have to try to remember the question, or else go back and forth. So negative 5.3 plus 3.5 times something, minus 0.62 times 4.5. Minus 0.62 times 4.5. All right. And I got negative 29.7. Great thing about modern calculators is often they'll change things to a fraction for you. As you can see, mine, if you look over at the right where it says negative 29.7, if I touch this button there, it changed it to negative 297 over 10. It used the exact same trick that I was explaining to you. The last decimal place was the tenths column. They moved the decimal 1 to the right and then put it over 10. So we want it as a decimal low since everything else is decimal, so negative 29.7. This one also is in decimals, so we'll leave it in decimals. We could do it all on our calculator at once. When we've got multiple steps going on in a fraction, like in the numerator and the denominator, it's often a good idea to do the whole numerator and then do the whole denominator and divide as my last step, because I always have to divide as my last step. Otherwise, I have to be very careful with my order of operations. So that's what I'm going to do. I'm going to just do the numerator, 4.2 minus 8.5 times something. (4.2 minus 8.5 times negative 1.3). So that's my numerator, 15.25. I'll just write that down. My denominator, I can actually do that one in my head, 3.6. So if I do 15.25 divided by 3.6, I got 4.236111, etc., repeating. If we're not told how many decimal places we should go to, my general rule of thumb, I'll go to 2 decimal places unless I'm told otherwise. So to round this one, the second decimal place is the 3, but I need to look at the next one, which is the 6. 6 tells me to round up, so I'm going to round that to 4.24. What else? Oh, powers with rational bases. Yes. Powers with the rational base are calculated the same way as powers with integer bases. So in other words, if I have, let's look at an actual number example. If I have 2/3 all raised to the exponent 3, it means, and I mean by all, I mean that 3 is on the brackets around it. It means multiply 2/3 times itself 3 times. So then I'd have 2/3 times 2/3 times 2/3. So that's actually going to be the same as if I had 2 to the exponent 3 over 3 to the exponent 3, isn't it? Since I'm only multiplying the top together, 2 times 2 times 2 is like 2 to the 3. And since I'm also only multiplying the bottoms together, 3 times 3 times 3 is like 3 to the 3. So 2 to the 2/3, like this, all raised to the exponent 3, can be done most easily, I think, by understanding that means I can just do the top to the exponent 3 over the bottom to the exponent 3. And that's what this part down here is showing. This would be the general rule here. If we have a minus sign out front, notice how, or let me say it this way, remember that exponents are only on what they're immediately beside. So this n here, actually, again, let's look at real numbers, probably a bit easier. This 3 here is only on the 2/3. This negative sign is not affected by that exponent 3, which means that it doesn't go away, but it just gets written out, and then everything else carries on as it was. So then I'd have negative 8 over 27 because that minus sign out front. If, however, there's a negative sign inside the brackets, like there is in the one below, right? We got a 3 with a negative 2/3, but the negative's inside the brackets in this case, the same rule applies. As above, it's going to be the same as if we had negative 2 to the exponent 3 over 3 to the 3. And so it would all depend on whether the exponent is even or odd. If we have an odd exponent on a negative number, we've seen before, that comes out negative overall. If we have an even exponent on a negative number, we've seen it comes out positive overall because all the negative signs cancel out. This one's negative, that's why we end up with this negative answer here. And that's exactly what I was just talking about in the last line here. We've got, in this case here, we've got an even exponent. We've got 2. Because it's the same as, if I put that negative on the 2 here, so negative 2 squared over 3 squared, negative 2 squared is negative 2 times negative 2, positive 4 over 9. Whereas the one below it, we've got an odd exponent, So that's going to be the same as negative 2 to the exponent 3 over 3 to the exponent 3. And negative 2 times negative 2 times negative 2 3 times gives us negative 8 over 27. The bottom's always going to be positive. Another reason to try and make sure that we keep our signs on the top, always our negative signs on the top. Okay, we have what? A few examples just to work to put this into practice. So evaluate 4/7 squared. So think of it as 4 squared over 7 squared. 4 squared means 4 times 4, that's 16. 7 squared is 7 times 7, that's 49. And that's it. It's that easy. Example 2, think of it like negative 2. Put that negative sign up top. So negative 2 squared over 5 squared. Negative 2 squared means negative 2 times negative 2. That becomes positive 4. It's an even exponent. 5 squared is 25, so it's positive 4 over 25. Here we have fractions, rational numbers combined with exponents, order of operations. Looks messy, but if we take it step by step and are very careful, it doesn't have to be a hard question. So sometimes when we have long questions, I'll do multiple steps in each line if they're not related to each other, if they're separated. So I'll change this first fraction to an improper fraction, just for example. 2 times 3 is 6, plus 2 is 8 over 3. Put the negative sign up top. Change the other ones to improper fractions. 1 times 4 plus 3 is 7 over 4. Put the 1 up top. Okay. Keep the 5, 6. Keep the squared. That's all I'm doing in that step. Now, order of operations tells me I need to go do with what's inside the brackets first. So I'm going to have to add, well, subtract in this case, those two fractions. I'm going to need to work with this part here. That's what order of operations says to do first. So I'm not going to do anything with the negative 8/3. I can't really do anything with them. I need a common denominator. 4 doesn't go into 6, but 4 and 6 both go into 12, so that's my lowest common denominator. If I multiply the first fraction top and bottom by 3, I get negative 21 over 12. If I multiply the second fraction top and bottom by 2, I get 10 over 12. And they both have the negative signs there. That squared stays on the outside. Negative 8/3. Notice I'm not doing anything with this negative 8/3. It's just, I'm patiently waiting with that there until its time comes. I just keep writing it down, though. I keep writing it down. So for inside the brackets, I've got 12 on the bottom, and I've got negative 21 minus 10. So again, the signs are the same. Add them together, I get 31 with a minus sign, and then it's squared. But here's where I've done what I can inside the brackets. You might be tempted to simplify these signs, but that would actually be a mistake, because order of operations says that I have to deal with the exponent first. So that's going to be the same as, again, negative 8/3, not doing anything with that, but that's going to be the same as negative 31 squared over 12 squared. We've seen this a few times. Squaring, being an even exponent, is going to give me an overall even answer. Negative 8/3, keeping that there. 31, negative 31 squared is positive, and 31 times 31, well, what's that? 310 plus 31, 341? I think it's 341, but let's see, 31 squared. Oh, 300, oh my goodness, so far off. Not even sure what I was thinking. 961. Erase that, what I just said, out of your memory. I'm not sure where my brain had gone on that. I must have been doing too many videos. Anywho, 12 squared gives me 144. Feeling good about that one. Okay, this one's taking so much space, so I'm going to just go up to the top again. I'll use a line, this arrow, to show that I'm just going over here. Now I do need a common denominator. 3 goes into 144 48 times. I really should stop making predictions and doing mental math. Just going to embarrass myself. 144 divided by 3, 48. Okay, I did get that one right. So I need to multiply the top and the bottom of the first fraction by 48. So 8 times 48. 8 times 48 is 384. So getting a common denominator, I've got 384 over 144, because I had to multiply top and bottom by 48 to get that common denominator, plus 961 over 144. Again, I'm only going to add the numerators. In this case, I'm subtracting, so I'll subtract 348 from 961. 613. And the bigger number was the positive one, so it's a positive answer. So I could leave it like that. I don't think it's going to reduce. Or I could change it to a mixed fraction, but I don't feel any need whatsoever to do that. As long as there's nothing else that can go into this to reduce it, I'm done as far as I'm concerned. 613, I don't see anything that's going to work for that one, so I'm going to leave that. And the last one, again, we're given decimals for this one, so I feel perfectly legitimate, that it is perfectly legitimate to work with decimals in that, and we're going to need our calculator, as long as we do order of operations. So negative 3.2 squared. Squared is an even exponent, so we're going to get a positive answer. 3.2 squared is 10.24. So I'm going to just show a few steps as I go along. Now I have to do my powers, my exponents, before I multiply by negative 2. So I'm going to keep the negative 2 where it is, but I'm going to do 6.5 cubed. Because it's an odd exponent, I know my answer will be negative. So I'm just going to go ahead and write that negative sign in now. Then I can forget about it and just do 6.5. I already forgot what the number was. Yeah, 6.5 cubed. 274.625. All right. Now, this is where people get a little confused sometimes with these signs. I got a negative number inside the brackets, but I've also got this negative here. Here's how you should probably think about it. There's more than one way to think about it, but I'm multiplying this 2. Think of it like it's a negative 2. Think of it like the negative sign is with that 2. You know, you can call it a minus sign, you can call it a negative sign. It means the same thing. So think of it like it's a negative 2 times this negative 274. When I do that, that means I'm multiplying a negative times a negative, which is positive overall. So then I can just, again, forget about the signs, just multiply my answer times 2. And now I've got 549.25. And then I can add the 10.24. Forgot to do the plus sign, so plus 10.24, 559.49 is my final answer for this one. So again, if you're given something in fractions like example 3, you should work with fractions. If you're given something in decimals, it's okay to work with decimals. But don't automatically switch fractions to decimals, as some people want to do because they want to be able to use their calculators. You need to break yourself of that, because sometimes we're just expected to keep it as fractions. So, take a look at the homework and see what you can do with it.